All right, let's talk about something in math that honestly kind of trips a lot of us up: multiplying decimals. But I'm going to show you a super simple rule that is going to make it click every single time. Let's just dive right in.
So, take a look at these two problems. Be honest, which one makes your brain just seize up a little bit? For most people, it's the one on the left. But why? The numbers are basically the same.
Well, it all comes down to this one pesky little dot. That's it, the decimal point. It's the only thing that's different, but it turns a pretty simple multiplication problem into something that feels like a puzzle. But what if I told you there's a trick, a way to make that decimal point just vanish for a second, let you solve the easy version, and then pop it right back in, exactly where it belongs? This is what we call the ignore and restore rule. And honestly, it's more of a two-step math hack than a rule, and it's going to give you a ton of confidence next time you see one of these problems. Okay, so here's how it works, and it's just two simple steps. First, you literally just ignore the decimals. Pretend they're not even there. Multiply the numbers like they're regular old whole numbers. Then, and this is the secret sauce, you count up how many digits were after the decimals in your original question. That number is going to tell you exactly where to put the decimal point back in your answer. And hey, this isn't some random trick I found on the internet. This method is a real, legit part of the Cambridge Lower Secondary Math curriculum. It's used all over the world to help people build a rock-solid foundation in math, so you know it's a strategy you can trust. All right, you ready to see just how easy this is? We're going to try it out on a problem you can probably do in your head. This will be a quick win to prove the rule works before we tackle that bigger problem from the start. Here we go. Let's try 0.2 times 4. Looks simple, right? Let's use our new hack. So step 1, ignore the decimal. Poof! The decimal in 0.2 is gone. And what are we left with? Just 2 times 4, way friendlier. Which is, of course, 8. Simple. See? The ignore part is already done. And now for step 2, the restore part. We gotta look back at that original question, 0.2 times 4. So how many digits were sitting to the right of the decimal point? Just one, right? The 2 in 0.2. That's it. That's the only number after a decimal in the whole question. So here's the magic. Since our question had one decimal place, our answer has to have one decimal place too. So we take our 8 and we make sure there's one number after the decimal. That gives us 0.8. And we're done. See how that works? It's pretty cool, right? Now that you've got the hang of it, let's go back and absolutely crush that problem we started with. This is going to make it stick for good. All right, round 2. Back to the big one. 4 times 2.16. It doesn't seem nearly as scary now, does it? Okay, step 1, you know the drill. We just pretend that decimal isn't there. Our problem becomes 4 times 216, which gives us 864. You see, the heavy lifting is already over. Now for step 2. The restore part. And this quote from the Cambridge material just nails it. There are 2 digits after the decimal point in the question, so there must be 2 digits after the decimal point in the answer. It really is that straightforward. So let's do the count. In our original number, 2.16, how many digits are after the decimal? Well, you've got the 1 and you've got the 6. That's 2 digits. So now we know exactly what to do with our answer of 864. We just have to place the decimal point so there are exactly 2 numbers to the right of it. And there you have it. You take 864 and you count from the right, 1, 2, and bam, you plant the decimal right there. The answer is 8.64. Problem solved. Look, if you remember only one thing from this, let it be this right here. The number of decimal places in your final answer must equal the total number of decimal places in the numbers you started with. That is the whole game. That's the heart of the ignore and restore rule. So now you've got this little math superpower. And trust me, it's not just for homework. This is for figuring out a 20% discount when you're shopping, or for doubling a recipe at home. It's a practical skill for making faster, smarter decisions. So my question for you is, where are you going to use this handy little trick first?